Hello and welcome to the 3-Minute Quran Study, the place where science meets history. When analyzing the history of the Quran, it is of vital importance to reliably date the manuscripts. By far the best tool to do so is radiocarbon dating. But how exactly does it work? In the upper atmosphere of the Earth, solar radiation causes constant nuclear reactions. One result of these nuclear reactions is the creation of carbon-14 or C14. An unstable carbon isotope which decays at a fixed rate into C13 and C12. In the atmosphere, creation and decay of C14 have reached an equilibrium. Roughly 1 out of 1 billion carbon isotopes is C14. As plants grow, almost all of their organic mass is made up of carbon from the air, which is transformed through photosynthesis. Once the carbon atoms are inside the plant, they are locked in place. And the same is true for animals who eat those plants or animals who eat animals who eat plants. C14, which decays within an organism, will no longer be replaced by newly created C14 from the upper atmosphere. So when scientists find organic materials, all they need to do is to count the carbon isotopes. The fraction of C14 will then tell them the age of the object with amazing precision. It's relatively easy for a tree. Its carbon is straight from the air and therefore young, which means without much C14 decay. But what about parchment? It sounds straightforward. Parchment is made from animal skin, and since the animal consumed plants, we should find carbon that was young when the parchment was made. Hence, radiocarbon dating should provide accurate results, just as with the tree. Well, it's not that easy. For one, during the production of parchment, the animal skins are treated with all kinds of chemicals, for example with calcium carbonate, also known as chalk. Chalk is a carbon compound made up of very old carbon, meaning carbon without any C14 in it as it has already decayed. If carbon from this chalk gets mixed in with the carbon from animal skin, the C14 count will be skewed and make the parchment appear much older than it really is. But there's more. In the Middle East, parchment was typically made from goats. Goats are grazing animals eating grass directly off of the ground. Unlike trees which get their CO2 directly from the atmosphere, grass is so close to the ground that it also picks up CO2 which is gassing out of the soil. Some of the CO2 which comes from the ground has organic origins. It's the result of decomposing organic matter underground. As such, it can easily be decades older than atmospheric CO2 and hence have a lower C14 count. But particularly on alkaline soils in warm and dry regions, there's also a lot of mineral CO2 outgassing. Here we're once again talking about very old carbon without any C14 isotopes. Grass which picks up these mineral carbon isotopes can appear to be decades if not centuries old while still being alive. Goats which eat this seemingly ancient grass will then also appear to be much older when counting their C14. If only 1.2% of the carbon making up the parchment is old, either from mineral CO2 or chalk, it will appear to be 100 years older than it really is. So while radiocarbon dating is certainly a great tool, it may not be the tool that fits the problem of dating parchment. And indeed, that's precisely what we see. For example, did you know that the Sana manuscript has been dated at least 8 times? Most of us are familiar with the Oxford dating, which places it between 595 and 658 AD. But a French team also dated it with a likely origin between 388 and 535 AD. What we are probably looking at is the result of dating 2 different pieces of parchment made from animals who grazed on different soil or whose skin was treated differently before producing the Quranic manuscript in question.